Hi there. Every successful drone flight, whether you're flying commercially or for recreational purposes, both begin in the same spot with the Preflight Checklist. Let's have a look. The first item on the checklist is to identify the airspace classification. Although there are many designations within the national airspace, they all tend to fit into one of these four groups. Number one is uncontrolled airspace, or usually referred to as Class G airspace. In Class G airspace, you are generally free to operate within the scope of your licensure, within all of the rules and regulations that apply, with a very high regard to public safety. Secondly, there's controlled airspace. This has several different designations and classifications. Class D, Class B, and Class C airspace generally refers to that airspace surrounding airports at different altitudes in varying configurations. Thirdly, there's restricted airspace. Restricted airspace can be temporary or can be permanent, and it generally refers to military operations areas and areas that pertain to national security. Fourthly, there's special use airspace. This airspace is usually temporary and can pertain to a wide variety of special activities like air shows and other activities that are approved by the FAA. Now at first, this may seem a little complicated. But to make things easier, the FAA, in partnership with Aloft Industries, have developed two applications called Before You Fly and Aloft. They're available on Google Play or on your iOS App Store for either iOS or Android. The program itself allows you to zero in on your current location. The map depicts different types of airspace by colored circles. Choosing anywhere on the map will instantly show you if you're good for takeoff and clear to fly, or whether it's restricted and special authorization is required. It will also give you the opportunity to apply for that authorization. It will tell you what type of airspace it is and what altitude you're allowed to fly at. To find out more about airspace classifications, log into the FAA website. Now let's take a look at item 2 on the checklist, checking the current weather conditions. FAA regulations are very closely tied to the weather patterns that exist during flight. The atmospheric conditions that must exist before you can fly are called flight minimums. The airspace classifications we looked at help you to understand where you can fly. But looking at the weather data can help you understand when you could fly. Without knowing the weather conditions, it would be very difficult to comply with the FAA's regulations pertaining to drone flight. As a recreational pilot, you must conduct your flights generally during the daytime hours only. You are permitted to fly during civil twilight, which begins 30 minutes before sunrise and ends 30 minutes after sunset. But in such cases, the FAA requires the use of anti-collision lighting that's visible to other aircraft from a minimum distance of 3 statute miles. At the time this video was made, only a licensed commercial pilot under Part 107 is eligible to apply for authorization to fly during the nighttime. Another example would be that weather conditions must be such that allows a pilot to fly no less than 500 feet vertically underneath the lowest cloud cover, as well as 2,000 feet horizontally beside the lowest cloud cover. In addition, you must have at least 3 statute miles of unobstructed clear visibility between your launch point where you're controlling the drone and the drone that's in the air. The FAA requires that you keep the drone in sight at all times during flight. Finally, the weather conditions must be such so as to allow you to always operate within acceptable safety parameters. So what type of weather conditions are we talking about? What do you need to collect? Let's find out. The first thing you're going to need is a measurement of the atmospheric temperature. You'll find that your drone will fly differently and have different behavioral characteristics depending on the elements that exist in the current weather pattern where you're flying. Secondly, you'll need to know the relative humidity. You'll need to know the dew point. The dew point is a measurement of the amount of moisture that's in the air. You'll need to know the barometric pressure and note whether that's rising or falling. That could be an indication of changing weather. And we'll need to know the type of cloud cover that exists over the flight area. Cloud cover will have a lot to do with how and where you can fly your aircraft. You'll need to know the elevation of that cloud cover, and you'll need to know if there's any precipitation and what form that precipitation is in, rain, snow, or ice. For purposes of line of sight and for getting the proper exposure on the video and photos that you'll be taking, you'll need to know the ambient light levels. You'll need to know the wind speed. You'll need to know the direction of the wind. And try to plan that toward the end of your flight, your return to home notification will be bringing you with the direction of the wind, because that will take less battery and will get you home faster than if you're going in the face of the wind. Another important point is that you need to know the weather forecast. You may be planning your flight days ahead of time, and you need to take a look ahead and see what the weather is going to be like that day. The day you fly, you'll check it again and take a look at the radar and trying to get an idea of what the forecast is going to be in 2, 3, and 4 hours. You don't want to get caught in the middle of a thunderstorm while you're in the air. And if you're going to be flying during civil twilight, you're going to need an accurate time for sunrise, and sundown. If you would like more information about the weather and how it affects drone flight, log into aviationweather.gov, or if you'd like more formal training, you can log into thepilotinstitute.com. And that brings us to the third item on our checklist. Check all FAA advisories and notice to airmen. This information can be found on the Flight Services website. Although this primarily pertains to the licensed commercial remote pilot, it is also freely accessible to recreational UAS pilots. This website gives you real-time data on the weather and flight conditions, FAA advisories, current flight restrictions, and current UAS operating areas. The Flight Services website will provide you with a customized certified flight briefing the day of your flight. It's an invaluable resource that you can't afford to be without and can be accessed at www.1-800-WXBrief.com. The fourth item on the checklist is to perform a visual inspection of the entire flight area. This needs to be performed during the planning phase many days before the day of your flight, but it also needs to be performed again the day of your flight to confirm that nothing has changed. Failure to perform this part of the checklist will often lead to circumstances arising that you are not fully prepared to deal with. Nothing in aviation happens by accident. Whether you fail or succeed, there is always a reason. A successful flight is always the product of your taking the time to know what the potential hazards are and planning ahead of time to mitigate and respond to those eventualities should they occur. The first part of the walk around can begin right in your home by making use of Google Earth. Google Earth is a wonderful tool. You can zero in on the area and look close up at all of the different structures in the facility and get a good idea of what you're going to be dealing with when you're actually in the air. But that's no substitute for actually going and visually surveying the site in person. You need to determine whether that's a suitable place to fly your drone and whether there are any obvious safety concerns that need to be mitigated prior to flight. If there are, it's a good idea to take photos from different angles of the different problem areas so you can take your time and come up with an adequate plan to ensure safety. While you're there, you'll also have to take a look around and survey for possible alternate landing sites should the primary landing site become compromised. So we've visited the proposed flight area. We've done an initial visualization and walk around and identified several areas that we need to keep in mind during the flight. So we've photographed two sets of power lines running across the front of the property at an elevation of 150 feet. We visualized the tree line and determined the trees are approximately 120 feet high. The water tower by the landing area, we've looked up on the internet and it is 189 feet high. We visualized what's beyond the trees and found that there's just open fields. There's 2 high tension lines running through those fields at about 150 feet. And on the southernmost portion, there's a telecommunications tower that is 200 feet high. So from that, we can ascertain that a return to home altitude of 250 feet or above will be sufficient to clear all of the obstacles that exist within the flight area. And that will allow us to move on to phase 2 of our checklist, preparing your equipment for flight. Number 5 on the checklist is to inspect and charge all batteries. The first battery we'll look at is the flight battery. Drone batteries are not normal batteries. They're lithium-ion polymer batteries. These batteries have a polymer gel inside, and that gives them the property of being lightweight and holding more capacity during flight. Batteries need to be inspected every time that you use them. The number one enemy against battery life is overheating. Each time you fly them, you need to make sure that these little clips are working properly so that they secure into the drone and won't come loose during flight, causing you to have a power failure. Because these are so expensive, it's good to label these batteries and to have their service date on them so that you can keep a log of every time you charge them. For normal operation, they need to be deep cycled about every 3 months. Now this is a DJI intelligent battery, so it has circuitry inside that allows you to set how many days it will hold its charge before it automatically discharges to a resting state. You need to inspect the casing of the battery and make sure that there's no damage to it. You need to check that there's nothing being leaked. You need to check these pins and make sure that they're all intact. And you need to make sure that the battery is not swollen in any way. If they become overheated, they tend to swell and they have the capacity to cause an in-flight battery fire. Also, always make sure that you have enough batteries with you to do the job. The best charger to use is one that has a digital readout, so you can confirm what power levels are. The second battery we need to make sure is charged is the drone controller battery. It needs to be fully charged before each use. Other things that you might like to include on your checklist are making sure any radio equipment that you have is fully charged, or any lighting or GPS equipment that you may use. And that brings us to number 6 on our checklist, to inspect the airframe for damage. Failure to find damage prior to flight could result in this. But structural failure is completely preventable. Time looking for problems before flight is time that's very well spent. So let's begin. For the first part of the inspection, it's a good idea to leave the gimbal protective cover in place because it's so easily damaged. The first step is to deploy the rotor arms. And remove the battery. You want to make sure that the rotor arms are free to move. You need to check in these spaces and look for any type of obstruction that may limit its movement. We want to look at the battery compartment and make sure that it's completely free of any type of debris or dirt or anything else that would prevent the battery from being seated and locked into place properly. We need to inspect the electrical connectors to make sure that they're all there, that there are none broken, and that none of them are severely discolored. That would prevent the battery from making a complete connection. You don't want to suffer any type of power failure once you're in the air. Then we need to look at the outside of the airframe and do a 360-degree check. Pay special attention to where different parts come together. If they have received any type of force during a hard landing or anything else that you've encountered in flight, you may find that these pieces become separated, and that's a clue that you've got some structural problems that need to be dealt with. So if everything looks intact and you can't see any problems, you need to turn your attention to these hatch covers that you'll find on the outside of your aircraft. Depending on what type of drone you're flying, they may be in a different place. But you need to ensure that these hatch covers are correctly seated and firmly pressed into place, because it doesn't take much to jar them loose. Also, very importantly, take the time to manually open your SD port and verify visually that your card is indeed present in the drone. Prior to placement, you should have deleted what's on there or formatted it so you are prepared to hold the new information that you're about to gather. If the SD card is in there, we can close that back up. Again, making sure that it's well secured in place. So now we can carefully remove the gimbal cover. And look in the gimbal housing and just take your hand and make sure everything moves freely in all three axes. That there's no dirt or debris or anything in there that could restrict its movement or make it stick. You also want to inspect the heat vents. This particular drone has 2 vents forward, has vents on each side, and also has vents in the rear. These require consistent airflow so that your main circuit board remains cool and functioning in an optimal manner. We need to look at the rotor motor housings. If you'll look inside one, you'll see that there's space below the upper portion of the housing where debris and dirt can become lodged and prevent your rotor from turning. So just do a visual inspection and turn the rotor with your fingers. Make sure that it moves freely, and as the holes pass over the housing, just check for the presence of any debris or dirt that might be present. Sometimes you'll find a stone or dirt that's built up. I've even found a piece of plastic lodged in there that came from one of the propellers as they wear and get older. So do that to all 4 and make sure that everything's in working order there. It's always a good idea to have a can of compressed air handy that you can use to help keep the drone clean and free of debris. You want to blow out each of the motor housings and just make sure there's no dust or anything else that can start to build up and impair their function. You can blow out your battery compartment and the connections. Make sure that stays clean. Look at the portions where the rotor arms meet and just visually confirm that the cables that go from the circuit board to the rotor blades, that cable is not worn or frayed or discolored in any way. And again, you can just make sure that they're clear. Also, if your heat vents are also clear, just blow them out. You don't want any dust or anything preventing airflow. Well, the last item in this phase of the pre-flight checklist is to inspect proximity sensors. I almost forgot, you're going to need one of these. Now, it's clearly understood that all drones are different and each manufacturer have different configurations. Each drone has different capabilities. So I'm going to approach this step in a very general way and leave it up to you to adapt the essentials to whatever particular drone that you're flying. I'm currently using the DJI Mavic 2 Pro, which has a rather unique configuration. It has a proximity detection system that tells you when you're getting close to an object and gives you audible warning. You can also set the controller for automatic obstacle avoidance. But what it boils down to for a checklist is that it's a configuration of cameras and infrared sensors to detect the proximity of the aircraft to the objects around it. This particular configuration has a 360-degree access view. I have two sensors in the front. I have sensors on the side. There are sensors in the rear. I have sensors in the top. And if I flip it open, there's all kinds of sensors along the bottom here. And the only thing we need to do is to visually inspect these sensors and make sure that none of the lenses have been cracked or damaged to ensure that it functions properly. And once you confirm that, the only other thing that you can do is to clean them. So all I use is a simple lens cleaner, and I just go over each sensor and make sure that they're clean, that there's no dust or smudges or anything else on them that might interfere with them picking up the proximity of an object. Doesn't take very long to do, and if you do it each time that you fly, it will only take you a couple of minutes. I also use this opportunity to clean the lens filter on my camera, make sure that the images I take are as clear as they can be, and you need a clean lens to do that. I always keep a lens filter on the outside of the camera so that the actual camera lens itself is not exposed to the environment. So it tends to stay very, very clean and reduces the number of times that I need to clean it. And after that is complete, you can replace your gimbal protector. Make sure it's secured into place, and you can replace the battery that you had in the drone before you started. When you replace these, keep in mind that unless they seat properly, they will not lock into place and can cause you problems and give you error messages on your controller. So just take a second to line it up properly, and then with equal force on both sides, just press it into place, listen for that signature click, and then test to make sure it's securely fastened. It's a well-proven fact that 3 months from now, if it was not written down and documented, it never happened. I'd like you to consider the need to keep regular flight maintenance logs. It would give you an opportunity to document what problems you found, what corrective measures that you took, and what regular maintenance did you do on the drone prior to flight. In the event of an investigation, you might be glad you did. And that brings us to our third and final phase, executing the mission. Item number 8 is to select an appropriate launch site. And whatever site that you choose needs to be away from people, It needs to be clear of any obstacles. It needs to be clearly visible, both from the ground and from altitude. And it needs to be large enough to conduct your pre-flight run-up. Most pilots use a bright orange landing target so that it can be seen easily from your return home altitude. The launch site itself needs to be surrounded by safety cones so that people know what area you're going to be launching and recovering from. The safety cones will keep people out of that area and ensure safety. Item 9 on the checklist is to inspect and install the rotor blades. A quadricopter has 4 individual blades that are divided into 2 pairs. Each rotor blade needs to be individually inspected for any type of cracks, dents, or damage, and your rotor blades need to be in near perfect condition. It's good to look at the blades sideways and confirm that there's no warping or bending. You'll also need to turn each blade over and inspect the coupling that goes in to each motor housing. These small arm clamps are the only thing that hold your rotor blade to the drone. Okay, we've gone over a lot of information. We've looked at a lot of procedures and a lot of different items on the checklist. But now we come to the most critical part, where we go through the sequence that actually takes your drone from the ground and puts it into the air. Now, there are many drones. There are many different controllers. There's many different pieces of software. There's different applications and different uses. I'm not trying to teach you how to fly a DJI drone. What I'm trying to do is teach you a thought process, an approach that you can take, think through, and adapt to whatever type of drone you're flying in whatever type of situation that you find yourself in. Now, you stayed with me this far, so don't go away. This is the fun part. Let's have a look at the final launch sequence. So getting this far into the checklist allows us to prepare for launch. The first thing we need to do is attach any auxiliary equipment that you intend to use. This equipment might include landing gear, a locator beacon, strobe lighting, or a payload. You need to activate your aircraft radio so that you can monitor the CTAF and Unicom frequencies. Now we're ready to place the aircraft on the launch pad. Please make sure the power is off. Let's go through the initial power-up sequence. Activate your anti-collision lighting and activate your locator beacon. Then you're free to power on the aircraft. Pick up your flight controller and power that up. As it powers up, ensure that your firmware is up to date. Now we're ready to perform the systems check. This is what tests your avionics for flight. If anything's going to go wrong, this is where you're likely to find it. So don't rush through this process. Confirm that your return to home altitude is set correctly. Also confirm that your maximum altitude is also set. Check that your return to home function has been activated, and set your low battery warning switch to whatever power level you want to be alerted at. I usually keep this around 25%. Set what action is going to take place in the event of loss of signal. The most common setting is return to home. Check the compass calibration. The compass is highly susceptible to magnetic interference. Make sure that your home point coordinates are updated correctly and double check that on the map, because that's the point that your drone is going to return to if the return to home function is initiated. You need to confirm that your compass is functioning normally. You need to determine that your IMU is functioning normally. Verify that your ESC status is normal. And you need to determine that the vision sensors are also online and functioning normally. You need to ensure that return to home obstacle detection is in the on position. Ensure that the forward-facing radar is in the on position. If these avionics systems are not functioning properly, your drone could suffer a flyaway and you'll lose it. Make sure that your controller has acquired and locked on to satellites. Most drones require at least 6 satellites to function properly. Check the signal strength of the flight controller and the aircraft and make sure that they're up to full strength. Check your power levels and verify that the controller and the aircraft are fully charged. Confirm that it's putting out enough voltage to support your flight. If all of these avionic systems are functioning normally, we can move on to perform the aircraft run-up. If you're going to be using visual observers, radio them to check in and confirm that they're ready. Then broadcast your intent to launch. Now we need to check and make sure that our launch area is clear. At this point, you're free to activate your rotor motors. Next, you want to lift the aircraft off the pad and bring it to a low altitude hover between 2 and 3 feet. Just allow it to hold its hover and assess whether it's stable or not. The drone should be able to hold its hover with a great deal of stability. Then you need to test the aircraft's directional response to your flight controller's commands. This is accomplished with slow, smooth movements, moving the drone forward and then to each side, then bringing it back to center and reestablishing your hover. How your drone responds to those commands will tell you a lot about the health of your drone. Okay, we've surveyed the flight area and taken pictures of any areas that we felt would be a problem. We've calculated our return to home altitude. We've looked at the weather. We've looked at the airspace. We've determined if Lance approval will be necessary. All that we've done comes down to this. The buck stops here. It's the PIC, or the pilot in command's, responsibility to make the final decision to go or to abort the mission. Thank you so much for watching this presentation. I hope it helps. Please be kind enough to leave me some feedback in the comments. And if you have any requests for specific content in upcoming videos, please let me know. Fly safe.
506, couple areas of moderate precipitation. First one 11 o'clock, 15 miles, moving to the north, 3 miles in diameter. The other one 12 to 1 o'clock, about 20 miles, moving to the north, that one's 5 miles in diameter. Your current heading should keep you right about between both of them.